Hi, Callie Daniels here. Let's talk about inequalities, graphs, and related interval notation. I've copied a table from your textbook from section 2.9 Inequalities, and we'll just walk through these. This first case we read as all x such that x is less than a. So here we're going to include all numbers that are less than a, and a represents a number and x is a variable. It can stand for a variety of numbers. Now, let's substitute a number for a, such as 3. So here I've got all x less than 3. So 3 is standing in for a. All numbers less than 3, find 3 on the number line, and then highlight or shade all numbers to the left, which indicates less than. And with the less than symbol, the 3 is not included, so we'll use a parenthesis to indicate that the value 3 is not included. We'll use a parenthesis with a strict inequality such as less than. As far as the corresponding interval notation goes, as we describe all of these numbers on the number line to the left of 3, we always start on the left-hand side. Numbers from negative infinity up to 3, negative infinity, comma 3, we represent that. The 3 is not included. The infinity symbol, whether positive or negative, is not included as well because it's a direction and not a stopping place. So we always use a parenthesis within infinity or a negative infinity. As we look at our second case, all x such that x is less than or equal to a. So these are values to the left of or less than a. And here I'm going to use 3 for a again. So x less than or equal to 3. Here we get to include the 3 because of the equal to part. Let's shade those values less than 3 and equal to 3 as indicated by the bracket. Corresponding interval notation, we get to include the 3 and all those numbers to the left all the way back to negative infinity. Okay, we always put the smaller value on the left in interval notation to correspond to smaller values on the left with our graphs. Let's move along. All x such that x is greater than a, not including a. Our example, I'm going to say all x greater than 3. So find 3 on the number line. Values greater than 3 are to the right of 3 on the number line, such as, say, a number 4. This is a strict inequality that does not include 3, therefore we'll use the parenthesis. Now as we describe this interval, this graph using interval notation, it has 3 on the left, not included, and then all values greater than 3 in the direction of positive infinity. So positive infinity is to the right, and negative infinity is to the left on our number lines, okay? Lastly here, all x such that x is greater than or equal to a. I'm going to use the example all x greater than or equal to 3. Find 3, we get to include the 3, therefore bracket, showing that it is included. Then values greater than 3 and to the right. So the left side of our interval will include the 3 with a bracket, just like on the graph, in the direction of positive infinity as we include all these positive numbers to the right. So a positive infinity. You don't have to use the plus symbol with positive infinity. Showing the infinity symbol there signifies that it is a positive infinity. Your last case here in the table, all x such that x is a real number, that's just every number on the number line. So you would just shade all the numbers on the number line, and then the interval notation looks like negative infinity to positive infinity. So it's like negative infinity back here on the left to positive infinity on the right, okay? Let's look at some three-part inequalities as well. Again, I've got another table that I've just copied from the text, and these are the three-part inequalities which are going to wedge our variable in between a couple of numbers. So in this first example, all x such that x is greater than b, or excuse me, greater than a and less than b. In other words, it's between a and b. So notice these are strict inequalities, so neither a nor b are included. The example I'm going to use is all x greater than -1 and less than 2. So find -1 and find 2, and we'll include all those values in between -1 and 2, not including -1 and 2 because of the strict inequalities. In interval notation, just make it look exactly like your graph from -1 to 2. Parentheses showing that the endpoints are not included. As our second example, all x such that x is greater than a and less than or equal to b. Our example, all x greater than -1 and less than or equal to 2. So greater than -1 up to and including the 2. So notice we'll use a parenthesis that corresponds to a strict inequality to show that endpoint is not included, and we'll use a bracket with the non-strict inequality, meaning a less than or equal to, showing that that endpoint is included. Your interval notation will match the graph. -1 to 2. -1 is not included, the 2 is included. A couple more here real fast. As our third case, all x such that x is greater than or equal to a and less than b. Our example, all x such that x is greater than or equal to -1 and less than 2. So in this case, we include the -1. We do not include the 2. Then we show that all values in between those will satisfy this inequality, such as the number 0 or 1 or 1/2 would be solutions to this inequality. Lastly, here we go. All x such that x is greater than or equal to a and less than or equal to b. Our example, x is greater than or equal to -1 and less than or equal to 2. All right, so these are equal to inequalities, aren't they? Okay, they're non-strict, which means the endpoints are included. We get to include -1, therefore bracket. We get to include 2, therefore bracket, to show inclusion, and all the numbers in between. All right, so in interval notation, -1 to 2, brackets on each. Hey, let's pop back up there to that previous example and make its interval notation look just like the graph from -1 to 2 with parentheses. So if you can graph these, you can definitely write them in interval notation. There you go. Good luck with those.